So now let's solve this problem. A. States the parallelogram law of composition of two forces. So say the law. Parallelogram law of composition of two forces states that if two forces are represented by the adjacent sides of a parallelogram in magnitude and direction, then the diagonal of the parallelogram drawn from the point of intersection of the two forces represents their resultants in magnitude and direction. So, if you draw a parallelogram, it should be something like this. So if you draw this is parallelogram. So and it will have a diagonal this way. So this diagonal is resultant. So don't cram the row. So now let's trace the row one by one to draw the parallelogram. Okay, parallelogram law of composition of two forces states that if two forces are represented by the adjacent sides of a parallelogram in magnitude and direction, so this is one vector, this is another vector. So these two vectors are represented by the adjacent sides of a parallelogram. So that's what the law is saying. You will see a vector must have a length and arrowhead. So that arrowhead is the direction, while the straight line is the length, so which is the magnitude. So this line is magnitude, while this arrow is direction. So that is what the magnitude and direction means. So parallelogram law of composition of two forces states that if two forces are represented by the adjacent sides of a parallelogram in magnitude and direction like this, then the diagonal of the parallelogram drawn from the point of intersection of the two forces represent their resultants in magnitude and direction. This is the point of intersection of the two forces. So the diagonal drawn from this point of intersection of these two forces represent their resultant in magnitude and direction. So the straight line is magnitude, while the arrowhead is direction. So that is why we say magnitude, the straight line, direction, the arrowhead. So that's it. So that is the law. So you can use the diagram to remember the law. So where this is resultant, R. So that is just parallelogram law of vectors. So if you want to complete this to form parallelogram, so that is when you can move this one, let's say this way, and this one, you see, so it has formed parallelogram. So meaning this one is parallel. So look at it now. So I move this one here. So it's parallel to that one. Move this one too here. It's parallel. So it has formed parallelogram like this. So if you remove the two, then it is now the adjacent side of the parallelogram. So this is adjacent side of the parallelogram. So let me complete it back. So I've completed the parallelogram now. So the diagonal is this. So this is resultant. So the angle which the two vectors make with each other is this. Y here will be angle which the resultant makes with the horizontal, as in like that. So we have stated the law. So let's say the B part, the calculation. So B, 5 forces: P Newton, 2 Newton, 5 Newton, Q Newton, and 8 Newton, acting on a body as shown in figure below, are in equilibrium. Calculate the magnitude of the force P and Q. So we have numbers here. So let me put the numbers. So I forgot to type the numbers, so I can type it here. So this is P Newton, this is 2 Newton, this is 90 degree. So why this is Q Newton, then this is 8 Newton. So those are the forces we have, and this, the force here at this 90 is 5 Newton. So like that. Now those are the forces we have in the question. So P Newton, 2 Newton, 5 Newton, Q Newton, 80 Newton. So now, how can we find the value of P and Q if this body is in equilibrium? Now, if this body is in equilibrium, so let me reproduce the diagram, so for better understanding. So we have straight line, so it's not straight enough. So I have a straight line, I have another one like this, then I have one here, that's P. I have another one here, that's Q. Then I have another one here, this Q, so that's 2. So now this is 0 degree, this is 180 degree, so this is 30 degree, 45 degree, 270 degree, 90 degree. So this, the force here is P Newton, the force here is 2 Newton, the force here is 5 Newton, the force here is 8 Newton, and the force here is Q Newton. So this is the diagram. So how can we find the value of P and Q? So let me remove this question, so to have space. So delete this. So let's find P and Q. Before you find P and Q, you have to know sign convention here. Remember, this is from 0 to 90. 0 degree to 90. So it's moving this way to 90. From 90 to 180. 180 to 270. 270 to 360. And that is 0 back. So from here, this is my vertical, because this is from 0 to 90. So I'm taking this line as my vertical. Take notes, why this line as my horizontal. So that's what I'll do. So this one is vertical, the other one is horizontal. Please take note of that direction. So now let's resolve. So you need sign convention here. So for my vertical, I'm representing all the angles to the vertical as cos. That is horizontal as cos. This is my horizontal. So this 30 degree is to the horizontal. Since total angle here must be 90, then the angle here is 15, because 30 plus 45 is 75. 90 minus 75 is 15. So that means that small angle is 15. From here to here, see the breakdown of everything so you can grab. So that means from here to here is 30. So P makes an angle 30 with the horizontal. Remember, this line is my horizontal line. Then 2 Newton makes an angle of 15 plus 30 to the horizontal. That's 45 to the horizontal. So there is one more thing, the question. Here is 60 degree is given. So it's part of the diagram. So that is 60 degree. So that means if that place is 60, total angle here will be 30. Since sum of angle here is 90, so 60 plus 30 is 90. So that means this Q Newton is 30 degree. This Q Newton is 30 degree to the horizontal. So we have all our angle. So now I'm taking all the angles to the horizontal, so that my horizontal will be cos. So I've done a video instead of using SOHCAHTOA, so you can actually know where to take as cos and where to take as sine. So usually where the angle lies is always cos. So now I'm taking all the angles to the horizontal, so I can consider my horizontal as cos. If you are taking the angle to the vertical, just like this Q Newton is to the vertical, so that means the cosine I will use there is sine. So that is, if it is to vertical, that vertical is cos. And if I'm using 30, it is this 30 side that will be cos. So it depends on the angle you are using. But one thing is that anywhere the angle lies is cos. So now I'm choosing all my horizontal angle, so that my horizontal will be cos. If in your own calculation you are choosing all the vertical angles, then all your vertical must be cos as anyone, then horizontal will be sine. But in my own case, I'm choosing all the horizontal angles, so my horizontal will be cos and my vertical will be sine, like that. Now, what are the sign convention here? So vertical is sine. So sine 90 is plus 1. So this is plus. Sine 270 is minus 1. So this will be minus. Horizontal is cos. So cos 0 is 1. That will be plus 1. So this sign is plus. Cos 180 is minus 1. So this sign is minus. So that is the sign convention we are using. So for this horizontal now, this is positive, this is negative. For the vertical, this is positive, that is negative. So like that. That is the essence of this angle you see here. This degree. So sine 90 is plus, so that is plus 1. Sine 270 is minus 1, so that is it there. Cos 0 is 1 plus 1, and cos 180 is minus 1, as in that is it. So now resolve everything to both horizontal and vertical. Now, for this system to be in equilibrium, sum of all the forces in horizontal direction must be 0. So for this system to be in equilibrium, sum of all the forces in the horizontal must be 0. Now add all the forces in horizontal direction. So now this is P. So resolve it to horizontal. So the angle of P to the horizontal is this. So that is 30 degree. And remember, horizontal is cos, and that to this side is plus. So that means the resolution there will be P plus P cos 30. So that is plus P cos 30. Then for 2 Newton, the total angle to the horizontal is 30 plus 15. That's 45. So and the sign there is also plus. So this will be plus 2 cos 45. Remember, all your horizontal is cos. So we are through with that. This 5 is on vertical, so we don't need that. And this Q, you can resolve to the horizontal, so just move it this way. The angle is 30 degree and the sign is minus, so that is minus Q cos 30 degree, so everything equals 0. So that's it, because this 8 is to vertical. So we have resolved all the horizontal forces, yeah, and make everything equals 0. So now what is cos 30? So I'll work with decimal points so that I can avoid long working. So this will be 0.8660p plus 2 cos 45. So that is 1.4142 minus cos 30 again. So the same thing as 0.8660q. So everything equals 0. 8660q. So everything equals 0. So we have 0.8660p minus 0.8660q, so it's equals to minus 1.4142. Like that. So this can be equation 1. So this is equation 1 because it relates to simultaneous equation. So to make the equation simpler, I can divide through by 0.8660. That is this divided by 0.8660. Here also by, as in divide everything here by 0.8660. So let's see what we have. So if you divide this one by 0.8660, it will remain P. Then minus this one too by 0.8660, it will remain Q. Then 1.4142 divided by 0.8660. So that is 1 minus 1.6330. So this is equation 1. So we have formed equation 1. So let's form equation 2. So let's see equation 2. Sum of all the forces in the vertical direction must be 0. Our equation 1 is sum of all the forces in the horizontal direction is 0. Now sum of all the forces in the vertical direction is 0 also. So to do that, pick all the forces again to the vertical. Remember, your vertical is sine. So we pick 13. So that means this is vertical. The sign there is plus. So this will be plus p sine 13. So it's cos 30 we use there. So if you are using, because I'm using 30, that means I'm using angle to the horizontal. But if you choose to use this p to the vertical, that is like this, that will be 45 plus 15, 60. Then your own will be like p cos 60, because anywhere the angle lies is cos. So if you are choosing here, that means the angle is lying on the vertical, it will be cos. So that means sine 30 and cos 60 is the same. So but for convenience and understanding, so I've taken all my horizontal angles. So all my horizontal is cos. Now all my vertical will be sine with the same angle. So now this will be plus, because the vertical is plus p sine 30. So for 2 the angle is 45. So that is 15 plus 13. To vertical is also plus. That will be plus 2 sine 45. Then this 5 is on vertical and it is plus. So that will be plus 5. Then this q is minus to the horizontal but plus to the vertical. So that will be plus q sine 30. Then this 8 is minus there. So that minus 8. Everything equals 0. So this is the sum of my forces to the vertical direction. So that is summation Fy is equals to 0. So that's it. So P sine 30 plus 2 sine 45 plus Q plus 5 plus Q sine 30, then minus 8. So sine 30 is 0.5. So this is 0.5p plus 2 sine 45. So that is 1.4142 plus 5 plus q sine 30. That is also 0.5q minus 8. Everything equals 0. So I can remove this diagram now, because we can actually solve the simultaneous and get P and Q. So okay, let me leave the diagram. Let me clear this. So you have to jot this. So from here we have 0.5p plus 0.5q, then add 1.4142 plus 5 minus 8. So that will be minus 1.5858. Everything equals 0. So that means 0.5p plus 0.5q equals 1.5858. So divide everything by 0.5. So we can have a simple equation. So divide everything by 0.5. So 0.5p divided by 0.5, that's p, plus 0.5 Q divided by 0.5, that's Q. Then 1.5858 divided by 0.5, so that's 3.1716. So this is equation 2. So we get our equation 1 and equation 2 now. So combine the two equations together and solve simultaneously. So anything you get there will be for P and Q. So this is equation 2. So bring it together and solve simultaneously. So this is our equation 1 and 2. So for these two equations, we use elimination method. So add the two equations together. So P plus P, so you get 2P equals, that is minus Q plus Q is 0. So equals minus 1.6330 plus 3.1716. So that will be 1.5386. So P is equals to 1.5386 divided by 2. So P is equals to 1.5386 divided by 2. That will be 0.769 Newton. So that is our P. So this force P is 0.769 Newton. So that means it's a small force. So now how can we find Q? So use equation 2 or equation 1, anyone you like. So from 2, P plus Q is 3.1716. That means Q is equals to 3.1716 minus P. So take P to the other side. That means Q equals 3.1716 minus P. So this is the value for P. So minus 0.769 approximately. So it's 93. So but I approximate. So Q is equals to 3.1716 minus 0.7693. So Q is 2.402 Newton. So that is our Q. So we have solved for P and Q. So that means P is equals to 0.77 Newton to 2 decimal places, and Q is 2.40 Newton. So that is our P and Q. So we have solved the equation. So that's it.